There are two aircraft sitting on the ramp at Nellis Air Force Base right now that look like they came from the same drawing board. Both are stealth. Both are fifth generation. Both were built by Lockheed Martin. Both carry the most advanced avionics ever installed in a combat aircraft. Both cost more per unit than most countries spend on their entire air forces in a single year. And yet every single pilot who has climbed into both cockpits, strapped in, taxied out, and pushed those throttles forward, every single one of them will tell you the same thing. These are not the same airplane. They are not even close to the same airplane. They are two completely different weapons designed for two completely different wars. And understanding exactly why, exactly what separates these two machines at the deepest level, is one of the most important stories in modern military aviation. Because the F-22 Raptor and the F-35 Lightning II are not rivals. They are not redundant. They are not the result of some budget committee building two versions of the same thing. They are the product of two separate visions of what air combat is, what it requires, and what winning actually looks like when the missiles start flying. If you have ever wanted to understand what separates the greatest fighter jet ever built from the most capable combat aircraft ever deployed, you are in the right place. And before we go any further, please take a second to subscribe. Over 98% of people watching right now are not subscribed. It costs you nothing, and it means everything to keeping stories like this one coming. Now let us get into this. To really understand why these two aircraft are fundamentally different weapons, you have to go back to the moment each one was conceived, because the philosophy behind a weapon shapes everything about it. The F-22 Raptor was born from a specific nightmare. That nightmare was called the Soviet Union's next-generation fighter threat. In the early 1980s, American defense planners were staring down intelligence reports about what was coming out of Soviet design bureaus, and what they saw scared them. The Soviets were developing aircraft that would potentially match or exceed the performance of the F-15 Eagle, which at that point was the undisputed king of the skies. The F-15 had an undefeated combat record. It still does to this day. But American war planners understood that technological advantages do not last forever, and the Soviets were closing the gap. The program that would eventually become the F-22 started as the Advanced Tactical Fighter Program in 1981. The Air Force issued a requirement for something that had never existed before in the history of aviation. They wanted an airplane that could defeat any known or projected Soviet fighter threat in within visual range and beyond visual range combat, while simultaneously being so stealthy that enemy radar systems would not be able to track it, while also being able to cruise at supersonic speeds without using afterburner, a capability called supercruise, while also being extraordinarily maneuverable at both high and low speeds. They wanted something that was essentially invincible in air-to-air combat. They wanted a pure air dominance machine, a fighter pilot's fighter, a weapon whose only job, whose entire reason for existing, was to kill enemy aircraft before those aircraft even knew it was there. That requirement produced the F-22. Now go back to roughly that same era, and another requirement was being written. Not for an air dominance fighter, not for something designed to kill other jets. This requirement was for a replacement for a whole family of aging aircraft, the F-16 Fighting Falcon, the AV-8B Harrier, and the A-10 Thunderbolt II, among others. What the Pentagon needed was a single aircraft that could serve multiple branches of the military simultaneously. The Air Force needed a multi-role strike fighter. The Navy needed a carrier-capable version. The Marine Corps needed something that could take off from short runways and even hover like a helicopter. And all three services needed it to be stealthy, affordable in large quantities, and capable of integrating with allied air forces around the world. That requirement became the Joint Strike Fighter program, which eventually produced the F-35. Two programs, two completely different sets of requirements, two completely different answers to two completely different questions. The F-22 answers the question of what happens when you build the ultimate fighter with no compromises. The F-35 answers the question of what happens when you build the most versatile, most connected, most capable multi-role combat aircraft in history. And every pilot who has flown both will tell you that difference is felt in every single flight, in every single maneuver, in every single moment behind the stick. Let us start with the F-22, because if you want to understand what air dominance really means, if you want to understand what it feels like to fly something that was built purely and exclusively to be better than everything else in the sky, you have to understand the Raptor. The F-22 is powered by two Pratt & Whitney F-119 engines. Each engine produces roughly 35,000 pounds of thrust with afterburner. Together, They give the Raptor a thrust-to-weight ratio that exceeds 1-to-1 at combat weight. What that means in practical terms is that this aircraft can accelerate straight up, vertically, like a rocket. It can accelerate while already moving at supersonic speeds. It can pull maneuvers that pin pilots into their seats at 9 times the force of gravity. And here is the part that still makes other pilots shake their heads. The F-22 can cruise at supersonic speed, somewhere above Mach 1.5, without ever lighting its afterburners. That is called supercruise, and it is one of the most tactically significant capabilities on the planet. Why? Because afterburner produces an enormous heat signature, an enormous infrared signature that heat-seeking missiles can track, an enormous visible signature that eyes and cameras can see, an enormous fuel consumption penalty that limits range and endurance. When the Raptor supercruises, it is moving faster than almost anything else in the sky, while burning less fuel than a jet using afterburner, and producing a significantly smaller thermal signature. It arrives at the fight faster. It can choose its engagement geometry from a position of energy advantage. It can run away from a fight faster than most things can follow, and while it is doing all of this, it is invisible. The F-22's radar cross-section has been described in various open-source documents as approximately equivalent to a metal marble. Some reports suggest it is as small as 0.0001 square meters in certain aspects. For reference, the F-15 Eagle, that the Raptor was designed to replace, has a radar cross-section somewhere in the range of several square meters. The difference between those two numbers, in the radar world, is not a small improvement. It is a generational leap. An enemy radar that can see an F-15 at 150 miles might not see an F-22 until it is already inside missile range, and by then, it is already too late. But stealth and speed are only part of what makes the Raptor what it is. The real genius of the F-22 is how those qualities combine with its aerodynamic performance to create something that has never existed before in combat aviation history. The Raptor uses thrust vectoring nozzles. Those nozzles can move independently up, down, left, and right, redirecting the thrust of its engines not just to push the aircraft forward, but to physically rotate it through the air at angles and rates that would be impossible with conventional control surfaces alone. Combine that with a fly-by-wire flight control system that is constantly making thousands of micro-adjustments per second, and you get an aircraft that can point its nose at targets that are behind it, that can change direction so quickly that the human inside is the limiting factor, not the machine. Pilots who have flown the Raptor describe a consistent experience. They describe it as an aircraft that does exactly what you think it should do before you have fully completed the thought. It is that responsive. One former F-22 pilot described getting into an adversarial training engagement against a highly capable fourth-generation fighter and said from the moment he rolled in, the fight was already over. Not because of anything he did tactically, but because of what the aircraft gave him before the first shot. He was faster, he was higher, he was invisible, he had already fired and was turning cold before the other pilot even knew he was there. That is what the F-22 was built to do. It was built to make the air combat engagement so one-sided that calling it a fight at all is almost generous. Now here is the number that shocks people when they hear it for the first time. The United States Air Force operates 186 operational F-22 Raptors. That is it. Out of the original program requirement for over 700 aircraft, production was cut, ultimately to 187 total aircraft built, with 186 in operational service. That means the entire operational F-22 fleet, the most dominant air-to-air weapon in history, would fit into a stadium section, and those 186 aircraft represent the entire air dominance reserve of the United States Air Force. No other country in the world has anything remotely comparable. China is working on the J-20. Russia has the Su-57, but neither of those aircraft has been tested in contested combat, neither has been proven at scale, and open-source assessments consistently place them behind the Raptor in raw air-to-air performance metrics. The F-22 is alone at the top, and every pilot who has flown it knows it. Now let us talk about the F-35, because this is where the conversation gets more nuanced, more complex, and frankly more interesting to a lot of people. Because the F-35 is not trying to be the F-22. It was never trying to be the F-22. And pilots who do not understand that going in often misread what the F-35 actually is. The F-35 is not a dogfighter. It is a quarterback. The F-35 Lightning II is the most sensor-fused, data-networked, battle-space-aware combat aircraft ever built. Full stop. Nothing else comes close. When an F-35 pilot straps in and takes the runway, they are not just sitting inside a fighter jet. They are sitting inside a flying intelligence, surveillance, and reconnaissance platform that also happens to be capable of delivering precision-guided weapons at stealth from ranges that make traditional air defenses largely irrelevant. The F-35 carries a suite of sensors that has no parallel in aviation history. The AN/APG-81 Active Electronically Scanned Array Radar is among the most advanced airborne radars in existence. The Electro-Optical Targeting System, the EWOTS, is a forward-looking infrared and laser targeting pod built directly into the airframe, invisible, flush-mounted, with no drag penalty. The Distributed Aperture System, the DAS, is a network of 6 infrared cameras arranged around the entire aircraft that together give the pilot a spherical 360-degree view of the airspace around them. Not a section of sky, not a cone in front. Everything. Above, below, behind, to the sides. All of it, all at once, fused together and projected onto the pilot's helmet visor. That helmet, the Joint Helmet-Mounted Cueing System, is itself a weapon. The pilot can look at a target, in any direction, and cue missiles to launch in that direction without ever pointing the nose of the aircraft at it. They can shoot at something behind them by simply looking at it. That is not a marginal improvement over previous systems. That is a fundamental change in the physics of air combat. But the most important capability of the F-35 is not what it can do alone. It is what it can do as a node in a network. The F-35 was designed from the beginning to be the most connected combat aircraft in history. Its multifunction advanced data link, the MADL, allows it to share sensor data with other F-35s in a formation using a highly directional, low probability of intercept communication link. What that means in practice is that a flight of F-35s does not function like 4 separate aircraft sharing radio calls. It functions like a single distributed sensor network with 4 separate weapon delivery platforms. One F-35 can be looking at a threat with its radar. Another F-35 in the same flight, with its radar off, completely passive, completely silent, can still see that threat on its display because it is receiving the fused picture from the rest of the flight. Then a third aircraft can take the shot, and the enemy never gets a single radar emission to guide a missile toward. The F-35 is fundamentally redefining what a combat aircraft is supposed to be. It is not just a flying gun. It is a flying nerve center, a flying intelligence hub, a flying command post that also carries bombs and missiles. And that is why when you talk to pilots who have flown both the F-22 and the F-35, they do not compare them as if one is better than the other. They compare them the way you might compare a championship boxer to a chess grandmaster. Yes, the boxer can fight. Yes, the chess player can think several moves ahead. They are both exceptionally dangerous, but they are dangerous in completely different ways, and putting them in each other's roles would be a disaster. Let us talk about what pilots actually say, because this is where the rubber meets the runway. Multiple pilots who have flown both aircraft have spoken on record, in interviews, in testimony, in public appearances, about what it is like to transition between the two. And the consistent themes are fascinating. When you move from a 4th-generation fighter like the F-16 or the F-15 into the F-22, experienced pilots describe a feeling of pure, raw, physical capability that they have never encountered before. The acceleration is staggering, the climb rate is staggering, the ability to maneuver is staggering. One pilot described pushing the F-22 into a max performance turn and feeling like the aircraft was cheating, like it was doing things that should not be physically possible. The aircraft felt like it was built specifically to embarrass anything else in the sky, and it was. When those same pilots transition into the F-35, the first thing many of them describe is disorientation. Not because the aircraft is difficult to fly. The F-35 is, by most accounts, easier to fly than the F-22 from a basic airmanship standpoint. The disorientation comes from the information environment. The F-35 is presenting the pilot with a volume and density of fused sensor information that initially overwhelms people who are not trained to process it. One pilot described it as the difference between looking through a straw and suddenly being given a full panoramic view of the battlefield from above. You have to learn how to use that view. You have to learn what to do with it. Because the aircraft is not just showing you what is in front of you, it is showing you where every friendly aircraft is, where every known threat is, what weapons are available to which aircraft in your formation, what the enemy radar coverage looks like, where the seams in that coverage are, and it is suggesting threat prioritization in real time. No aircraft in history has done that. And pilots who come from the F-22, as capable as the Raptor is, describe initially feeling behind the jet in the F-35. Not because the F-35 is faster or more maneuverable, it is neither of those things compared to the Raptor, but because the cognitive demands of operating the F-35 at its full potential are enormous. The aircraft is trying to give you a complete picture of a modern battlespace, and learning to use that picture effectively is its own discipline, its own art form. One pilot who has transitioned through both aircraft described it this way. He said, "Flying the F-22 makes you feel invincible. Flying the F-35 makes you feel omniscient." And in modern warfare, he said, omniscience might actually be more valuable than invincibility. Let us talk about the physical differences, because they matter enormously to understanding why pilots experience these aircraft so differently. The F-22 Raptor is a large aircraft. It is 62 feet long. It has a wingspan of 44 feet. It weighs roughly 43,000 pounds empty. Loaded for a typical air superiority mission, it can exceed 60,000 pounds of gross weight. It is a big, powerful, physically imposing machine. When you are sitting in the Raptor's cockpit, you are surrounded by the most capable fighter aircraft ever built, and you can feel it. The power of those two F-119 engines at full afterburner is not subtle. It is not polite. It is a physical sensation, a raw, primal force that pins you back and tells your nervous system something entirely unambiguous is happening. The F-22's cockpit is designed around the mission of air dominance. The primary flight and sensor displays are optimized for tracking and engaging aerial threats. The IASA radar, the AN/APG-77, is one of the most capable air-to-air radars in existence, with a range and resolution that gives the Raptor detection advantages over anything it will likely ever face. The cockpit ergonomics reflect the aircraft's purpose. Everything is positioned to help a pilot find, fix, track, and kill enemy aircraft quickly and efficiently. The F-35, by contrast, has a cockpit philosophy that is fundamentally different. The F-35 has a massive panoramic cockpit display, a single large touchscreen that dominates the instrument panel and replaces the dozens of individual gauges and small displays that traditional fighter cockpits are filled with. Everything is software-defined. Everything is reconfigurable. The pilot can customize what information appears, where it appears, and how it is presented, adapting the cockpit in real time to the evolving demands of the mission. The F-35 cockpit was designed from the beginning around the concept of sensor fusion. Everything the aircraft sees, its own radar, its own ETs, its own DAS, data coming in from other F-35s in the formation, data from ground stations, data from airborne early warning aircraft, all of it is processed, deconflicted, and presented to the pilot as a single, coherent, fused picture of the battle space. Not raw sensor feeds that the pilot has to mentally integrate. A synthesized, actionable picture. Pilots coming from legacy aircraft describe this as nothing short of revolutionary, and pilots coming from the F-22 describe having to rebuild their mental model of what a cockpit is supposed to give them. Because the F-22 gives you incredible individual performance data, and the F-35 gives you incredible collective situational awareness. They are two different languages, both useful, both powerful, neither one translatable directly into the other. Here is something that does not get discussed enough when people compare these aircraft, and it gets to the heart of why they exist as a complementary pair rather than as competitors. The F-22 is optimized for what is called the kinetic kill chain. It finds, it closes, it fires, it destroys. The entire aircraft is built around executing that sequence faster and more reliably than anything else in the sky. The F-35 is optimized for what the modern military calls the kill web. Not a kill chain, a kill web. A network of nodes, sensors, decision points, and weapon delivery platforms that collectively generate and execute combat power across domains and distances that no single platform could achieve alone. The F-35 does not have to be the one that pulls the trigger. In fact, many of its most important contributions to a modern air campaign have nothing to do with firing weapons at all. The F-35 can fly into denied airspace that would be suicidal for a non-stealthy aircraft. It can map enemy air defense systems. It can identify and locate radar emitters. It can track the movement of enemy aircraft. And it can transmit all of that information in real time to other platforms. An F-35 flying deep into enemy territory, collecting data with every sensor running, can feed that information back to F-22 Raptors, to naval vessels, to ground-based missile systems, to bombers, to commanders in rear areas, enabling all of those platforms to engage threats that they could not even detect on their own. That is a capability that did not exist before the F-35. That is not something the F-22 was designed to do. The Raptor was designed to survive and dominate in contested airspace through sheer performance. The F-35 was designed to understand contested airspace, map it, share that understanding, and enable a networked force to collapse it from multiple directions simultaneously. And when you put those two capabilities together, when you fly F-22s and F-35s in coordinated operations, you get something that neither aircraft could create alone. You get an air campaign that is both physically dominant and informationally dominant at the same time. The F-22 shuts down the enemy's ability to threaten the airspace. The F-35 shuts down the enemy's ability to understand the airspace. Together, they make it impossible for an adversary to fight effectively at all. Let us go deeper on the stealth comparison, because this is an area where people often assume the two aircraft are simply equivalent, and they are not. Both aircraft are stealthy. Both aircraft use radar-absorbent materials, edge alignment, internal weapons carriage, and carefully shaped surfaces to reduce their radar cross-section. But they are not stealthy in the same way, and they were not designed to face the same threats. The F-22's stealth is optimized primarily against the radar frequencies used by fighter aircraft radars, specifically X-band radars, because the F-22 was designed to survive and dominate in air-to-air combat against the most advanced fighter threats the Soviets and their successors could produce. Its stealth is exceptional in the frequencies that matter most for fighter versus fighter combat, making it extremely difficult for enemy fighters to detect and track it in a dogfight scenario. The F-35's stealth is broader in its design philosophy, because the F-35 needs to penetrate and survive against integrated air defense systems, against surface-to-air missiles, against ground-based radar networks that may operate across a range of frequencies. Its stealth was designed to address a wider threat spectrum. It is not as singularly focused as the F-22's stealth, but it covers more of the threat landscape that a multi-role aircraft operating in a complex anti-access area denial environment would encounter. The F-35 also has stealth advantages that result directly from its mission systems. The aircraft can manage its own electromagnetic emissions, selectively activating and deactivating its radar, its communications links, its electronic systems, in ways that minimize its detectability to passive enemy sensors. The F-22, because it is optimized for active engagement, has less emphasis on passive stealth modes. Both aircraft represent the leading edge of what is possible in stealth technology, but they represent the leading edge applied to different problems, and pilots who fly both know that the stealth on each aircraft feels different operationally, because it serves a different purpose in a different kind of fight. Now let us talk about the variants, because the F-35 has something the F-22 does not. The F-35 comes in 3 versions, and those 3 versions reflect the depth of the original design requirement. The F-35A is the conventional takeoff and landing variant, flown by the United States Air Force and a majority of international partners. It is the most capable of the 3 variants in terms of internal fuel and weapons capacity, and it has a built-in 25mm cannon for close-range engagements. The F-35B is the short takeoff and vertical landing variant, the STOVL version, flown by the United States Marine Corps and the United Kingdom's Royal Air Force and Royal Navy. This version incorporates a lift fan driven by the main engine and a rotating exhaust nozzle that together allow it to take off from a rolling start of a few hundred feet and land vertically, like a helicopter. The engineering required to make that work while maintaining the aircraft's stealth, its combat capability, and its survivability is one of the most impressive technical achievements in aviation history. The F-35C is the carrier variant, designed for catapult launches and arrested landings on aircraft carrier flight decks. It has a larger wing for improved low-speed handling, stronger landing gear for the violence of carrier-arrested landings, and a reinforced airframe to handle the repeated stress of catapult launches. The F-22 has no comparable variants. It was designed for one mission, one service, one environment. The Air Force owns it, nobody else. No allied nation operates it, in part because its technology is so sensitive that export has been legally prohibited. The F-35, on the other hand, is operated by more than 15 nations and counting. It is the backbone of a global coalition air power architecture that the United States and its allies are building for the decades ahead. That distinction, one aircraft locked to one service versus one aircraft shared across a coalition, is itself a massive strategic difference that shapes how pilots in both communities think about their machines. Let us talk about the weapons, because this is where the missions become visibly distinct. The F-22 carries its weapons internally, in 3 weapons bays. The main weapons bay in the center of the fuselage can carry up to 6 AIM-120 AIMRAAM medium-range air-to-air missiles, the primary beyond visual range weapon. The 2 smaller side bays can each carry a single AIM-9X Sidewinder short-range heat-seeking missile for close-in engagements. For air-to-ground missions, the Raptor can carry a limited internal payload, including small-diameter bombs, but this is emphatically not its primary mission. The F-22 can deliver ordnance to ground targets, but it does so the way a championship sprinter might lift a box. Technically possible, not what they were built for. The F-35 carries weapons in 2 internal bays and can also carry weapons on external hardpoints when stealth is not required. The internal bays can hold a mix of air-to-air missiles and precision-guided bombs, including the GBU-32 Joint Direct Attack Munition, the GBU-39 Small-Diameter Bomb, and the AIM-120 AMRAAM. When external pylons are loaded, the F-35 can carry an impressive variety of weapons, including cruise missiles, anti-radiation missiles for destroying enemy radars, anti-ship missiles, and additional air-to-air missiles. The aircraft was designed to be the most versatile precision strike platform in history, and its weapons loadout options reflect that. A pilot flying an F-35 on a given mission might be configured for pure air-to-air combat, or pure air-to-ground precision strike, or a mixed load that allows them to handle both threats in the same sortie. That flexibility is not an accident. It is the entire point. The F-35 was built to replace multiple separate aircraft that previously did these jobs separately, and its weapons capability reflects that ambition. Let us talk honestly about the criticisms, because any honest discussion of these aircraft has to include them. The F-22 program was cut drastically short, and that has real consequences. The Air Force originally wanted somewhere between 750 and over 700 Raptors. They got 186 operational aircraft. That shortfall has been debated extensively, with arguments on both sides about cost, industrial capacity, strategic necessity, and program management. What is beyond debate is that 186 aircraft is a very small number for a fleet that is expected to underpin American air dominance for decades. The F-22 is also aging. Its avionics systems were cutting edge in the early 2000s when the aircraft entered service, but the pace of electronic warfare advancement means that some of those systems are now less capable relative to modern threats than they were at introduction. The Air Force has been working on a significant modernization program, but upgrading the F-22 is enormously expensive and technically complex, in part because so much of its capability was built into the airframe and original avionics architecture, rather than designed for easy software updates. The F-35 has its own share of controversy. The program has been one of the most expensive defense acquisition programs in history, with total life cycle costs projected into the trillions of dollars over the aircraft's service life. Early versions of the aircraft had significant software deficiencies, performance limitations, and sustainment challenges that attracted serious criticism from oversight bodies and independent analysts. Some of those issues have been addressed in subsequent software and hardware updates. Others remain works in progress. The F-35 also has performance characteristics that, taken in isolation, sound concerning. Its maximum speed is limited to roughly Mach 1.6, compared to the Raptor's Mach 2+. Its thrust-to-weight ratio and instantaneous turn rate are lower than the F-22. Its sustained turning performance in a close-range dogfight is not competitive with the most agile fourth-generation fighters, let alone with the Raptor. But here is the critical context that experts consistently provide when these numbers come up. The F-35 was never meant to win close-range dogfights. If an F-35 pilot is in a close-range turning fight, something has already gone badly wrong with the mission plan. The F-35 is supposed to kill threats from beyond visual range, using its sensor suite and its network data to engage enemies before they ever get close enough for a knife fight. Its inferior dogfight performance relative to the F-22 is not a failure of the design. It is a consequence of design choices made deliberately in service of a different mission. There is a simulation that has been discussed in public that speaks directly to this distinction. In various red flag exercises and advanced tactical training events, when F-35s and F-22s have been pitted against each other in simulated combat, the results depend almost entirely on the rules of engagement and the tactical scenario. In close range, within visual range scenarios with certain constraints on what off-boresight missile shots are allowed, the F-35 can struggle against the F-22. The Raptor's raw performance gives it advantages that are difficult to overcome at close range. But in beyond visual range scenarios, in scenarios that allow the full use of the F-35's sensor fusion and networking capabilities, in scenarios that replicate the complexity of a real modern air battle, the picture is much more even. And sometimes the F-35's information dominance creates tactical outcomes that surprise even experienced F-22 pilots. Because in a modern high-end air battle, the side that sees first and decides first wins. And the F-35 was built from the ground up, to see first and decide first. When those capabilities are fully engaged, the question of who can turn tighter at low altitude becomes somewhat less relevant. Let us take a moment to talk about what the future holds for both of these aircraft, because the story is not finished. The F-22 is expected to remain in service through at least the mid-2030s, potentially longer depending on how the Next Generation Air Dominance Program, the NAD program, which is being developed to eventually replace it, progresses. The Air Force has been investing in modernization upgrades to keep the Raptor relevant, including improvements to its electronic warfare systems, its communications architecture, and its ability to integrate with the broader network that the F-35 has helped build. But the fundamental challenge remains. There are only 186 of them. In a major conflict against a peer adversary, those aircraft would be spread thin across multiple theaters, multiple missions, multiple contingencies. The F-35 is being produced in far greater numbers. The United States alone is programmed to purchase over 2,000 F-35s across the three variants. Allied nations will add hundreds more to that total. The F-35 will become the backbone of Western air power in a way that the F-22, through no fault of its own design, never could, simply because of the number of aircraft involved. What that means for air campaign planning is profound. An F-22 squadron arriving at a forward base in a contested theater is a powerful, concentrated capability. An F-35 wing arriving at multiple bases and aboard carriers across that same theater, integrated into a common tactical data network, sharing sensor pictures, coordinating kills across platforms, is something qualitatively different. Not necessarily more powerful in any individual engagement, but more powerful as a system, more persistent, more adaptable, more difficult for an adversary to counter comprehensively, because it is not one thing in one place. It is many things in many places, all talking to each other. There is a moment that pilots who have transitioned between these two aircraft often describe, and it captures the philosophical difference between them better than any technical comparison can. The moment comes during the first time a pilot who started in the F-22 world is sitting in an F-35, flying a training mission, and suddenly understands what the sensor fusion picture is actually giving them. They look down at the display, and they can see where every friendly aircraft is. They can see what the aircraft ahead of them in the formation is seeing on its radar. They can see the shape of the enemy threat environment, the locations of known radar sites, the tracks of hostile aircraft, the gaps in coverage that a strike package could exploit. All of it, all at once, on one display, without anyone saying a word on the radio. And in that moment, pilots describe a specific feeling, a feeling that they are not just a fighter pilot anymore. They are a node in something larger, something that no single aircraft could be or do on its own. One former instructor described it as the moment the jet stops being a weapon and starts being a mind. And on the other side, when a pilot who came up through the F-35 world climbs into an F-22 for the first time and pushes those engines into full afterburner and feels the aircraft climbing away from the earth like it is angry at the ground, they understand something different. They understand what it feels like to be the most individually capable air-to-air weapon that human beings have ever built. They understand what it feels like to be invisible and fast and so agile that physics seems optional. They understand what pilots have been chasing since the first air-to-air engagement in World War I. They understand the purest possible expression of aerial dominance. And that is the answer. That is why pilots who have flown both these aircraft say they are different weapons. Because they are not trying to solve the same problem. They were not built to fight the same fight. The F-22 Raptor is the answer to the question of what the perfect fighter aircraft looks like when you remove every constraint except performance and lethality in the air-to-air environment. The answer is a 70,000-pound supercruising thrust-vectoring stealthy killing machine that no adversary in the world has yet built a credible counter to in direct one-on-one air-to-air combat. The F-35 Lightning II is the answer to the question of what the perfect multi-role combat aircraft looks like when you are building for a networked, multi-domain, multi-service, coalition warfare environment where information is often more decisive than individual aircraft performance. The answer is a sensor-fused, data-sharing, electronically dominant, precision-strike-capable stealth platform that is simultaneously a fighter, a bomber, an electronic warfare aircraft, an intelligence collector, and a network hub. Neither answer is wrong. Neither aircraft is redundant. And the pilots who understand both will tell you that the United States Air Force is fortunate to have them both, because the adversaries they are built to face have neither. China is working toward it. Russia claims to be approaching it. Neither of those claims has been tested against the reality of what American fifth-generation air power looks like when it is operating as a system. And when it does operate as a system, when F-22s are clearing the airspace ahead and F-35s are networking the battlefield picture behind them, feeding targets to ships and bombers and ground forces across a theater, the resulting combination of physical dominance and informational dominance is something that no adversary military planner has yet found an answer for. That is not an accident. It is not luck. It is the result of decades of investment, of visionary program requirements, of engineering achievement, and of the pilots and crews who have dedicated their professional lives to flying and maintaining these extraordinary machines. The F-22 is not better than the F-35. The F-35 is not better than the F-22. The F-22 is the greatest pure air dominance fighter in history. The F-35 is the most capable networked multi-role combat aircraft in history. Those are two different sentences describing two different achievements. And when you are building an air power structure designed to deter, and if necessary defeat, the most capable potential adversaries on the planet, you do not have to choose between them. You build both, you fly both, you learn both, and you put them together in ways that the adversary cannot replicate, cannot counter, and cannot survive. The pilots who have sat in both cockpits understand this at a level that no briefing slide or press release can fully convey. They have felt the F-22 pull them skyward in a way that makes gravity seem like a suggestion. They have watched the F-35's display paint a complete picture of a battlefield that no single pilot could ever have seen before. They have experienced both flavors of what it means to be at the absolute edge of what human beings and their machines can do in the air. And to a pilot, every one of them will tell you the same thing. They are different weapons. They are both extraordinary. And the world is a safer place because both of them exist. If you learned something today about what actually separates these two incredible aircraft, hit the like button right now and subscribe if you have not already. There is a great deal more to explore about the machines and the people who fly them, and you do not want to miss what comes next.